Okay, chapter 9. Nothing happened. Okay. All right. Okay, discrete mathematics. Discrete mathematics. All right, this chapter is interesting too. There's a lot of different topics in this chapter. So let me run through what the chapter is going to be like, okay? So today, 9-1, we're going to do our basic combinatorics. Combinatorics, oh yeah. No, we're going to do permutations, combinations. Any of those mean anything to you? The multiplication counting principle. We're getting into like probability and statistics kind of stuff, okay? After that, we'll do the binomial expansion theorem. It's when you take a binomial and you raise it to the 5th power and you expand it all the way out using Pascal's triangle.
Oh, yeah.
Hat did that, regular algebra 2 did not. So, and then we'll do 9-3 and 9-4, which are on sequences and series. Arithmetic, geometric sequences. Remember those sum formulas, the sigma notation, summation, yes? And then 9-5 is going to be a mathematical proof by induction. It's one of my favorite ways to prove. Yeah, we're going to do, I quit, I'm done. Okay, but right now we're going to do all of 9-1 today, so we got to get started. We're on assembly schedule, we got to hurry. Okay, did we break this thing? It's like, all right, basic combinatorics. Combinatorics can be a very, combinatorics. It can be a pretty tough subject. We're just doing the basic ones, okay? We're going to be very basic today. Now, in college, you kind of have an option of taking 2 different types of branches. You can either go towards, like, calculus, which goes off into, you know, engineering stuff, if you want to be an engineer, stuff like that. Or you can go the other math direction, which is statistics, probability, geometrical stuff, combinatorics is in there. So I like the calculus route. I'm more of a calculus person. I took Calc 1, 2, 3, Diffie Qs, and like all those calculus problems. But this is like the other branch. And maybe you'll like this better. I don't know. So this might decide what you want to take next year too. You can take AP Calc or AP Stats or regular Calc. So let's get started. We're first going to start off by counting. Sounds easy. Counting. Okay, so far everything we've done has been pretty much continuous. We've had some discontinuous things when we graphed our rational functions. But discrete are going to be not continuous stuff. It's going to be like, when we talk about patterns, 2, 4, 6, 8, there's nothing in the middle. Those are just random dots, okay? So that's what discrete mathematics is a lot of times. All right, so here we go. Number 1. I'm just going to start you off with a problem. How many ways, and that's going to be the question today. How many ways can you arrange 3 objects in order? Can you arrange 3 objects in order? Okay, now 3 objects is not a lot. If I was going to talk about 20 objects, yeah, that would be tough. So 3 objects, let's say I have 3 books on a shelf and I want to rearrange them in different orders. How many ways can I arrange them in an order on a shelf? Okay. What they do is they actually give you this tree that they use. So I'll show you what they do. They take A, B, and C. Those are your 3 things. And if you choose A first, then you have 2 options from there. Right? Either B can go second or C can go second. And then from there, you only have one other option. C would have to go last, and B would have to go last. Okay? B, there are 2 options. You can go to A or C. After you go to A, you'll go to C, and after you go to C, you'll go to A. And then C has 2 options. C would be A or B. After A, you would go to B, and after B, you would go to A. So if you were to count these in this tree diagram, we have, let me see, we've got 1, 2, 3, 4, 5, 6. Wow, that looks really messy, huh? There are 6 ways to arrange, and we just listed them all, okay? Now, I would not want to do this if I had, 20 different books on a shelf and I was going to order them. Or when you talk about runners in a race, how many ways can they finish first, second, third, stuff like that. So there's going to be some shortcuts that we're going to learn to get us there. All right, but first thing we're going to do is this is going to help us do it in an easier way. It's called the multiplication counting principle. Multiplication counting principle. And it says this. It says, if an event can occur in R1 ways, so we have an event, and it can, I don't know what's going on with this pen of mine. Hold on. It can, what's that? No. I didn't break it the first time either. That was the app. The app was terrible, and I fixed it. They fixed it. Okay, let's say an event can occur in R1 ways, R sub 1, and another event can occur in R2 ways, okay? And then another event can occur in Rn ways. Then the way that they can all occur together is called the multiplication counting principle. You take R1 times R2 times all the way to Rn. And that will tell you how many ways they can all happen together. So if you didn't want to draw a tree for that last one, you could do this. How many different ways can I choose the first place person? Like if I was going to list these books A, B, and C, how many can go in the first slot? 3 of them, right? Okay. Then how many can go in the second slot? 2. Once you've chosen one for the first, there's only 2 left that can go in the second spot. So there's 2 of them. And then how many can go in the third spot? That would be 1. Multiplication counting principle says you take all the ways that it can occur, first, second, third place, and you get 6 ways. It's nice. You don't have to draw your tree out every time. Okay? So, JM. Does that mean something to you?
My initials.
Your initials, yes. Number 2. How many different 2-letter initials are there? How many different 2-letter initials are there? Okay. I don't want to list them all out. AA, AB, AC, AD. That would take a long time. That's horrible. But what I can do is this. I can find out how many different initials are possible for your first name. How many initials are possible for your first name?
26.
26 letters in the alphabet. Yes, very good. How many different letters are possible for your last name? 26 again. Anybody have double, like first name, last name initials? There's no doubles in here? Oh, mine's KP. No, nobody.
You know Muhammad's only like 8 letters?
Muhammad?
Yeah.
Okay.
There's more.
Great, okay. And then what you do is you take those 2 and you multiply them. What is that? What's 26 times 26? Is it 576? I don't know that perfect square. Does anybody know 26 squared? No?
676.
676. Oh, I'm off by 100.
How many what?
Yeah, you're going to need your calculator for these. Let's get those out. I got it. All right, so 676 different possible 2-letter initials. That's pretty cool. Okay, how about number 3? How about your license plate? Do you have a car? Ooh, I don't have one. Oh, you did?
Yeah.
Good, congratulations. Okay, your license plate in California, just not a truck, but like a car. Yeah. So when I was in high school, my dad made me memorize mine, and mine was 2YQL546, and I remember it because he would ask me just randomly, "What's your license plate?" Dang it! So I didn't have to memorize it. Okay. But what this is these. But my license plate, everyone's license plate out there, unless you get like a special kind, yeah. They follow the same pattern. They follow this. It's a number, followed by 3 letters, followed by 3 numbers. Okay. So how many possible license plates are there? License plates. If you follow this with no restrictions. I know they're going to take out things like if the 3 letters were ASS, they probably wouldn't have a license plate like that, or FUQ, like stuff like they take out, I don't know, whatever. They probably take out bad things that you would be like, oh, look at that guy's license plate, Okay, But let's not do that. Let's just say how many possible there are total. So we would go, how many numbers?
10.
There's 10. Well, actually, yeah, there's 10. You can have 0. I don't know if they put 0 as the first number, but yeah, let's say that there's 10. There's 10 numbers that can go in that first spot.
Do they do 0 and O?
No, that's the other thing, yeah. There's a lot of different restrictions on these, but we'll just find out like all the total. 26, 26, 26. Okay, there's 3 letters in a row, so there's 26 letters to choose from, and then 10, 10, 10. Times 10, times 10, times 10. All right, let's see, can our calculator handle that?
No.
It's 10 to the 4th times 26 cubed. Ooh, it did. 175760000. Wow. That's a lot. A lot of license plates. Okay? Now, let's say that we do this. Number 4. I'm just going to make up a license plate for a different state. Let's say that this license plate is going to have 6 digits, okay? Or 6, things. And it's going to be 3 numbers and then followed by 3 letters with no repeats. Okay? So how many possible ways would there be? I'm sure that a state wouldn't do that, but let's just pretend, okay? These are kind of fun. So 3 numbers, 1, 2, 3. So there's a first number, second number, third number. We're going to find out how many can occur for those, and then followed by 3 letters. So how many numbers for the first spot? 10. No repeats now. 9. 8. Perfect. And then 26, 25, 24. Okay? So you have to get rid of whichever one. Like if I had a Z here, then there's only 25 to choose from. Okay? And that takes into account all the different ways. 10 times 9 times 8 times 26, 25, 24. And yes, this is a very, very calculator-friendly chapter. There you go. 11,232,000. Okay, now that's part A. Part B, that's just counting principle. That's pretty easy to do when it's just like we have this event, this event, this event. So like how many different uniforms do you have at home that you could wear? Well, you have, let's say, 5 shirts to choose from, 5 shorts to choose from. You have 25 outfits, right? Did you ever know that you had that many outfits with your uniforms? Yeah. Or you could even like choose from a skirt or a shirt, but you have to choose a shirt and a skirt, not a shirt and shorts. You would not be allowed to show up to school that day. Okay, here we go. Permutations and combinations. Permutations. And you know what I like to do? I like to kind of put these side by side. And combinations. And they're very different, but people mix them up all the time, okay? All right, permutations are going to be the number of ways that you can order things. Okay, it's just like the last things that we were doing, but there's actually a formula that's coming up. It's the number of ways that you can put things in order. Okay, combinations is going to be the number of ways chosen when order doesn't matter. Number of ways when order does not matter. And you're like, but order always matters. It actually doesn't. Let me give you an example. If I had 10 runners in a race, and I asked you how many ways can these 10 runners come in first, second, third place? Order would matter. It's a race, they're racing, okay? Now, combination would be, what if I had 10 people in student council, and I wanted to choose 3 of them to be in a group, to maybe a dance committee or something? Would it matter which order I chose those kids in? No, they would be in one group, right? ABC, see this? ABC is different than BCA. Order matters. Over here, ABC is the same group as BCA. They're the exact same thing. Okay. Also, permutations. Under that, we can also have n factorial. factorial. Have you ever seen n factorial before? It's pronounced n. No, I'm just kidding. I'm just kidding, it's not. All right, n factorial is multiplication. It's when you take something like 5 factorial, that's equal to 5 times 4 times 3 times 2 times 1. Yeah, it's also on your calculator. Did you know that? Uh-huh. Okay, so if you go to your calculator and we want to do 5 factorial, I would go 5, and I'd go to math, and the ones that we're going to use in this chapter are all in the same spot. It's PRB, which stands for probability. Now, I'm going to save you a whole second of your life. You can actually arrow that way and get there quicker. Did you know that?
You can also up arrow and it goes all the way to the bottom.
Oh, dang. I didn't. That's exciting. I learned something new every day. Okay. Anyways, these are our probability stuff. See this NPR? We're going to use that. That's permutations. NCR will be combinations. We're going to use that. And there's factorial. So if I go 5 factorial, it tells me it's 120. 5 times 4 times 3 times 2 times 1. Okay? 120. All right, so knowing that, let's do some problems here. Number, what are we on, 3? Sorry, I didn't mean to scare you. 4? Number 4. That alarm today sure scared me. Yeah. Oh, it's number 5. Well, I was given a test during that alarm. Yeah. And it was like, oh, man, it's bad. Okay. All right, let me go ahead and start off with something like this. Let's take the word dragonfly. Do you like bugs?
They always use that word.
They do? How funny. Well, dragonfly is a lot of words that and none of them repeat. That's probably why they chose this. We want to find out how many different 9-letter words can we make. Okay, they're not going to be real words. But if we took dragonfly and we rearranged these, okay, there's 9 letters to choose from. None of them are repeats, so your answer would be 9 factorial. Because in the first spot, there's 9 to choose from. After you choose one for the first, then there's 8, 7, 6, okay? Now, we'll call that letter A. Letter B. So how about butterfly? We're just going to stick with our insects here. Is butterfly an insect? I don't know.
Yeah, I said so.
Okay. It's a bird. Okay, sweet. All right, butterfly. Now, butterfly has some repeats. See those T's right there? They repeat. So if I took a new word and made it a T and T, that's going to be the same word because you can't distinguish between the T's. It's the same letter. So what you want to do for butterfly is you want to take your 9 factorial and you want to divide out the repeats. And since T happened twice, we're going to divide by 2 factorial. Bless you. Okay? So 9 factorial, I'm sorry, I probably should have told you what 9 factorial was. If you do that on your calculator, it's 362,880. That's how many words there are. So your next project is to list them all. No, I'm just kidding. That's your Thanksgiving project. You're welcome. Take the letters in Thanksgiving and write how, no, I'm just kidding. All right, butterfly, if you do 9 factorial in your calculator, 9 factorial, bless you, divided by 2 factorial, that would be 181. That gets rid of a whole bunch of them, huh? 181,440 different words. Okay, what if we have multiple repeats, like the word bumblebee? These are all 9 letters. It's very exciting. Bumblebee. Okay? So let's take bumblebee and find out how many letters there are. Because the word B, 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 L, whatever, is going to be the same as if you take any of those B's and mix them around, right? So you got to take out all the repeats. So it's 9 factorial divided by. How many B's do we have? 1, 2, 3. So 3 factorial. What else repeats? The E repeats 3 times. 3 factorial. Okay, so you divide those out. Now, if you're going to put that into your calculator, make sure you do 9 factorial divided by parentheses. 3 factorial times 3 factorial. Okay? Because people will mess that up. And you get 10,080. Wow, we went all the way from 300,000 plus. There you go. Okay, now let me go ahead and tell you, we need to go over those combinations pretty soon, but let's say one more with permutations. Permutations, what we're going to do is you take n objects r at a time, and you end up with something called NPR. And NPR is to take n factorial and divide n minus r factorial. Now you don't need to know that. You don't have to know that formula, okay? NPR is going to be found in your calculator. All right? So what you do is you take the number, n is the number of total objects that you have, and r is the how many you want to take at a time. Take at a time. Okay? So this really works well. This formula works well when you're taking like 7 runners in a race. You need to find out how many ways they can finish first, second, third. Okay? So here we go. Last one of these, then we'll get over to the other side. R is taken at a time. The number taken at a time. Okay, let's say that 16 actors are trying out for these parts. And they're answering a call for the 7 dwarfs in Snow White. 16 actors, and they are answering a call for the 7 dwarfs. Can you say dwarfs nowadays or not? Dwarfs in Snow White. Have you ever seen Snow White? It's kind of creepy that she lives with all those people. Okay. How many ways can the director cast them? So, how many ways? Now, order does matter here, okay? Because someone trying out for Doc is not going to be the same person trying out for Sneezy, right? That would be weird. So he could choose these in different ways. So there's 16 to choose from. We're going to do 16 permutations of 7. You can also use the counting principle. You can put your 7 dashes and go, there's 16 for this dwarf, 15 for this one, all the way to 7 of them. But the permutations, that'll help you too. So you go 16 math PRB to 7. Whoa. 5, 7, 6, 5, 7, 6, 0, 0. That's a pretty steep number. Really big. Okay, let's go over and do our combinations now. All right? I'm going to go back over here. All right, so combinations is when order does not matter. Permutations, you can use the counting principle. Combinations, you cannot use the counting principle, okay? Combinations is NCR. It's the same thing. You have a number of things that you're taking, and you're taking them R at a time. But in this case, NCR is n factorial divided by n minus r factorial. It's the same exact formula, but then we're also going to divide out r factorial. We're dividing out all of our repeats. Okay? Because like I said, the group ABC is the same group as BCA. So let me give you an example of this. Number 7. All right, suppose that a cook chooses 5 potatoes from a bag of 12 potatoes. Okay? You're going to choose 5 potatoes from a bag of 12. How many ways are there to choose them? Okay? Order doesn't matter. These potatoes are not coming in first, second, and third place. Okay? So you're getting a group of potatoes. You're taking them out of a bag. How many different ways can you choose 5 from a bag of 12? You would do 12C5. You would not want to do 12 times 11. You can't do it that way because it's a group of things coming out. So you go to your calculator and you plug in 12 first. Go to NCR, 12 choose 5 gives you, and these are going to be lower numbers because they're dividing out all the repeats. 792. Okay, here's an interesting. Anyone play poker out there? Like 5-card poker? Okay. How many different 5-card poker hands are there? How many different 5-card poker hands? Yeah, you got to know your cards though. Some of you guys have never played with cards. Maybe it's a sin to play with cards. I don't know. Back in the day it was. So how many 5-card poker hands are there? Now, if I took my 5 cards and I'm given 5 cards, and I decided just to rearrange them in my hand. Do I have a different hand? No. It's still the same hand, right? Right? So it's a group. It's a group of cards. Order doesn't matter. What order I place them in my hand. If I place, this one here, that one there, but then I go, oh no, I want to move this one over here, I still have the same 5 cards. Okay? So that's why you would use C in this case, combinations. So how many cards are there? Playing with a standard deck. No jokers. You guys are the only jokers. 52 cards. Do you know something about cards at all? 52 pickup. Yes. Did you ever fall for that?
Yep.
Me too. I think we all have. 52 C5. You go to your calculator, you go 52 C5, and there's a lot of hands in poker. 259 or 2,598,960 different poker hands. That's a lot of poker hands. Okay, anyone like pageants? Do you like to watch the Miss America? Yes. All right, Miss America, right? Let's say that they're down to their 10 finalists. Woo, it's getting crazy. They're down to their 10 finalists, okay? And they have 51 contestants. Why 51, do you know? Were you
States.
Puerto Rico. Yeah, there's someone in there. Someone else, right? Isn't there like, is it Puerto Rico?
Puerto Rico?
Yeah? District of Columbia. You were close. Same thing. Yeah. Okay. Now, does it matter? They're all 51 standing up there, and they're going to choose 10 of them to be the finalists. Does it matter what order they choose them in? Maybe to the girls it matters because you want to get picked first, but it doesn't matter. This is not placing them in order. It's picking 10 of them to be in the final group. I always think of groups as combinations, groups. So there's 51, and they're going to choose 10 of them. Man, these judges, they have a lot to do here. How many different options are there? Whoa! My calculator did this to me. Does your calculator ever do that to you? They put that E there? Yeah. Do you know what that means? Yeah, it means 1.27 times 10 to the 10 in this case.
Wow.
It's a big number. They put it in scientific notation for you, almost. They could have, but okay. All right. So that would be your combinations. Now, we're going to go down here. Part C. This is the last part. Now we're going to have a little bit of combining them together. Combining our combinations. Okay, let's say that number, what are we on, 8, 9, 10? 10, jeez, all right. Let's say that you are the coach of a basketball team. Do you think that's an easy job? No, I wouldn't think so. Actually, I coached basketball for 3 years, horrible. Coach of a basketball team. I was not good at it. I'm not saying the kids were horrible. I was just not, it's just not good. Okay. And on a basketball team, you want to have 5 starters, right? You got to pick your 5 starting players. But people play different positions. So let's say you have you have 2 centers. Centers, that's that big guy that's in the middle, or girl. 2 centers to choose from.
Oh.
Yeah. I know, you're going there. That's good. Let's say you have 5 forwards on your team and 4 guards. What are these words, right? This stuff's hard.
This is basketball.
Yeah, this is the basketball one they gave me in the book. Maybe these are old words. I don't know. But they'll tell you that for your 5 starting players, you need to have 1 center. You need to have 2 forwards. Does that spell forwards at all? Not at all. You have to have 2 forwards and 2 guards. Okay? So, you cannot take, how many total are there on this team?
11.
There's 11. Okay. You cannot do 11, choose 5. You can't do that. Okay? Do you know why? Because 11, choose 5 would include 5 forwards being chosen. You don't want to put 5 forwards out there. That would be bad. I'm assuming, I think so. I mean, I coached for a little while. I don't know for sure. But I'm pretty sure that's bad. So here's what you do. You have to do a combination also with the multiplication counting principle, okay? So here are your events. You have to choose a center, you have to choose a forward, and you have to choose a guard. Okay? So this is your number of centers, or the ways that you can choose a center. This is the ways that you can choose a forward, and this is the ways that you can choose a guard. You're going to take those numbers, you're going to multiply them together. So how many different ways can you choose a center from these two players? That would be 2, choose 1. Okay? Your forwards. How many forwards are you choosing from? 5. And how many are you taking? 2. 5, choose 2. And then finally, your guards? 4, choose 2. Perfect. And you get each of those individually. It's a lot of calculator work. And there's 120 different ways to make a starting lineup of 5 lineup. Starting, I don't know, what do you call that? It's just starting players. Crazy, right? Like Mr. Branderhorst has a lot to think about. 120 different ways. He probably stays up at night thinking about those things. Or there's usually people that should start. I was never one of them. All right, last one, number 11. Do you like pizza?
Yeah.
Wait, what? You don't like pizza?
I do, but I avoid it.
Oh, dang, you have self-control. Must be nice. Okay, suppose we have pizza, and let's say that we have 10 toppings to choose from. Do you like lots of toppings or no toppings?
Lots.
Lots, yeah. Like a salad yeah, it's good. I know, like at Pizza Kitchen, the California Pizza Kitchen, they have like a pizza that comes with a salad on top. My dad ordered it, and I knew what he was ordering, and I was just waiting for him to get it. He got it. He's like, what is this? It was so funny. I didn't tell him. Sorry, Dad, if you're listening. Okay. Let's say we're going to do 2 parts. Let's say that they give you an option. You get to choose 3 toppings for free. Okay? Cheese is not a topping. Cheese already comes on there. They let you choose 3 toppings for free. They tell you the toppings are pepperoni, mushroom, sausage, onion, green pepper, bacon, prosciutto, black olives, green olives, and anchovies. Nasty. Okay. How many different combinations of pizzas are there going to be? Okay, are we going to use permutations or combinations? Are these things in a race? Are they trying to come in first, second, third? No. There's 10 of them, and you're going to choose 3 of them at a time. Okay, this is not that bad. This is not that hard. You will get some tricky ones in your homework over the weekend.
What is a pineapple pizza?
Ew, I hate that.
Exactly.
Sorry. All right, letter B. Now, this question is hard at first, okay? This is going to ask you if you can choose any number of toppings that you want. Any number of toppings. Okay? This is a hard question because it's hard when you like first think about this, because you can choose 1 topping and there's 10 to choose from. You can choose 2 toppings and there's 10 to choose those. You can choose 3, you can choose no toppings at all. There's so many, but do you really want to find all of those and add them up? No, you don't. Okay, so this is what you want to do. You want to think of it this way. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say this is olives. How many choices do you have for olives? You have 2 choices, yes or no. 2 choices. 2 choices, 2 choices. You get 2 to the 10th. 2 to the 10th ways, which ends up being 1,024. By the way, no toppings is in that, because it'd be no for all of them. It would just be a cheese pizza. That's there. That's listed there too. All right.